Okay, hi everyone. My name is Matt, and today I'm going to break down how I came up with the machine learning solution to predict energy consumption. During the exploratory data analysis, I found that the data is not ordered. There are outliers and skewedness. The attribute has weak correlation to the target variable. I found that there are similar weekly pattern as you can see in the graph between the current week and the previous week during the certain time that the energy peak usage peak, and this suggests us using time series analysis and approach to generate new features such as hour, day, month, etc. Since the pattern show it respond to date and the time. And then for the model, we chose LSTM and XGBoost because both model can handle continuous data since the target variable is continuous. LSTM work well with time series and insensitive to gap length. This is also shown in the literature tree. And XGBoost is robust to outlier. Tree-based model does not require pre-processing. It can utilize parallel computing to handle big data. Since the data we use is small, if we decide to scale it up, we can process for 2 years worth of data using XGBoost. And XGBoost is similar to gradient boost, which is used in other paper that predict energy consumption, and it show excellent result. For the train test validation, we use time series cross validation. We use time series cross validation because it does not make sense to use feature data to predict the past. So it also give better indication on how well our model perform. We use the train and validate to fine tune our parameter, and we do the scaling and normalization if required. So during for the performance measure and evaluation, we use mean square error and mean absolute error to evaluate the model, since MAE is less sensitive to outliers. From the result, we can see that the difference between the train and the test is low, which show us that we don't overfit the model, and the error score is low, which show us that we don't underfit the model. And the graph show that our model can accurately predict the general trend, but it's not good enough to predict the outliers. So this is the actual data and the prediction data. Evaluation and limitation. I think our model is good enough since the error score is low and it is not underfit or overfit. The result compared to other paper using the same data and similar technique show that the result is not too far off. So overall, I think the model is good enough to predict the general trend. The limitation is that the XGBoost is some kind of greedy algorithm, so maybe it's not the most optimal solution produced, and the model is not good enough to predict the outliers. So according to the literature review, according to the paper by Kanda Nedo, they improved their score by having new features such as light that has good correlation with the target variable. He also generated new features such as the number of seconds from midnight and SM, which also has high correlation to target variable. They use Boruta package to check for feature important and selection. This help reduce the model complexity by filtering only the important features. The light and NSM are the top two features from the Boruta result. Candanedo experiment show that the generated and added attribute model has better performance compared to the one without it. So the conclusion is generate new feature to improve the performance is possible. And then for the second literature, that Wang mentioned that single prediction model is unstable and less accurate. It is unstable. Learner may introduce various output by the slight change in the input. To combat this, Wang proposed using assemble bagging tree (EBT). The assemble method combine the output of multiple tree. In the result, Wang showed that EBT accuracy is better than classification and regression tree. Wang also mentioned that there are limitations to the method, such as increase in computation time and complexity. To offset this, we can utilize the high-speed computing resource of computer nowadays. So the conclusion is that assembler method consists of multiple predictor combined showed excellent performance. And in regarding to literature review 3, predicting energy consumption is hard due to the delays in time series and long-term intervals event. To solve these issues, Young suggests using long short-term memory (LSTM). Although we also use it, LSTM is a type of a recurrent neural network. Due to its unique design, which the neuron is hidden layer in the hidden layer can receive input from the input layer as well as perceived from the last moment. The loop structure made LSTM to be able to learn crucial time series characteristic. This is why we use LSTM. The result in the paper showed that the performance of LSTM compared to traditional machine learning method is much superior. Its RMSE score is 3 times better compared to the second best method, which is ERF. So the conclusion is like LSTM is suitable for time series and is the state of the art for energy prediction. And literature for talks about like missing data in energy consumption is not avoidable and surely encounter. To deal with this, we could Shapey suggests using multiple imputation, which gradually fill the missing data with each iteration. Another method suggested by Shapey is maximum likelihood, which substitute the missing value through assumption of the boundaries of the distribution. And then to handle large amount of data of energy consumption, Shapey is using the power of cloud computing. Cloud is highly scalable and capable of process large amount of data due to its resource, which we struggle with if we using XGBoost, but we don't have the resource. So what improvement can be made to so that our model has high accuracy and can be used? One thing that we can add is more data to accurately predict, since the data since there are low number of peaks. We only use like 4 months worth of data since it's really small, and we can also generate new feature that accurately separate the peak energy usage. The feature we generated, like number hour of day, doesn't clearly separate the outliers and the general trend. And then another improvement is like instead of predicting like 10-minute interval, like because it is very hard, like to predict second energy consumption in second is more harder. So instead of predicting by the minutes, we can predict by the hourly, which is more easier. The pattern in the left does not match perfectly compared to the right, which has been aggregated by the hour. Today, like for example, today, like 12 p.m. we had lunch, but next week we'll have lunch at 12:20. There's like a slight delay. That's why we suggest using aggregating, like instead of creating new feature, like predicting by the hour instead of predicting by the minute. If you can see like the difference here, like it doesn't match perfectly, but if we aggregate it by the hour, it's much better. So another improvement is that the literature review show that assembler method that combine multiple predictor provide better prediction and is more stable. We can try different assembler method rather than XGBoost, although we have used LSTM in the project, and it suggests that LSTM is suitable for time series problem. According to the literature tree, we can increase the amount of training data and process using cloud, according to literature 4. And this is all the reference. Thank you.